In this video, I want to have a look at solving harder inequalities. So we're going to be looking at problems that involve unknowns in the denominator of an inequality. So for example, our first one, we're going to have a look at x squared minus 1 over x is greater than 0. So this x in the denominator is going to make this problem a little bit different to a lot of the other inequalities that we've solved before. So in the past, if we had a question that looked like x squared minus 1 over, say, 7 is greater than 0, our first step would be to multiply both sides by 7 to get rid of that denominator. The problem is that it's not just a number, it's not a constant, it's an unknown. So because we don't know the value of x, or because x can take a lot of different values, if x was positive, we could just multiply it through, but we don't know if it is or not. If x was negative, if we multiply an inequality by a negative number, it switches the direction of our inequality sign. So we don't know whether it's positive or negative. Now there are a lot of different methods we could use to solve these inequalities. I'm just going to show you one today, okay? But there are other ones as well. So because we can't multiply by x, because we don't know if it's positive or negative, we're going to multiply by x squared, because x squared, if we square something, it's always going to be greater than 0. It's always going to be a positive number. So we're going to multiply both sides of this inequality by x squared. So here, that x squared would cancel with the x, so we'd end up just having x outside of x squared minus 1. So we're going to have that is greater than 0 times x squared, but 0 times x squared is just 0. And now we can have a look at this. We're going to factorize this out a bit more. So we're going to have x outside of this x squared minus 1. That's the difference of two squares. So we can write it as x plus 1, x minus 1 is greater than 0. So we're going to have a look at this now. We're going to graph this function. So we know that it's going to have roots at x equals 0, x equals minus 1, and x equals 1. So x equals 1, x equals minus 1. So it's going to go through those 3 points. We also know that it's a cubic because it's got 3 x terms. And if we were to expand it, the x cubed term would be positive. They are all single roots as well. So we know it's going to come down here and cut through each of those 3 points and end up coming down this way. So it's going to look something like this, just very roughly. So we've got our sketch of this function, but we want to know when this function is greater than 0. So that's going to happen when this red line is above the x-axis, so it's greater than 0. So that's going to happen in this region here and in this bit up here. So our final answer to this will be this bit here, so x is greater than minus 1 and less than 0, and x is greater than 1. So it's between minus 1 and 0, and it's greater than 1. Like I said, there are other ways to solve that, but I just want to show you what this function would look like if we were to graph it and we wanted that function greater than 0. So I've just opened up GeoGebra and I've written in the function x squared minus 1 over x, and it's drawn that function, what that curve looks like. So we wanted when this function, that x squared minus 1 over x, we wanted when that was greater than 0, so when that was above the axis. So that was in this region here, so that was between minus 1 and 0, and it was also in this region over here, so that was when x was greater than 1. All right, so let's have a look at a second example. So our second example, we're going to have 2t plus 1 over t minus 2, and we want that to be greater than 1. So again, we can't just multiply both sides of the equation by t minus 2 to get rid of that denominator, because we don't know whether t minus 2 is positive or negative and how that would affect our inequality. But we do know that t minus 2 squared is always going to be positive. So we're going to multiply both sides of that inequality by t minus 2 squared. So over here, one of those would cancel with the bottom, so we just end up with t minus 2 outside of 2t plus 1. And that's going to be greater than, well, 1 times that is just going to be t minus 2 squared. I'm going to go through and expand all that out. So we'd have 2t squared plus t minus 4t minus 2 is greater than, if we expand this side out, we'd have t squared minus 4t plus 4. Simplifying, we'd have 2t squared minus 3t minus 2 is greater than t squared minus 4t plus 4. And then if I bring all of this over to the other side, so I'm going to subtract t squared, so we just have t squared. I'm going to add 4t, so we'd have t. And I'm going to subtract 4, so we'd have minus 6 is greater than 0. And now I've got a quadratic that I can factorize. So I would have t and t. We want two things that multiply to give minus 6 and add to give 1. So we're going to have minus 2 and plus 3. Now if we were to sketch what this quadratic looks like, we know that it's going to have roots at positive 2 and negative 3. And we know that because this leading term is positive, that it's going to be concave up, so it's going to start up here and end up here as well. And they're both just single roots, so it's going to cut through like this. And we want to find when that quadratic is greater than 0, so again above the axis. So these ones over here. So that's going to happen when our x is less than minus 3 or our x is greater than 2. So x is less than minus 3, x is greater than 2. So these are our two solutions. Oh, hang on, they should be t's, not x's, sorry. So these are our solutions to this original inequality. Now let's again have a look at what this original graph looked like. So the function 2x plus 1 over x minus 2 will give us a curve called a hyperbola. So it's giving us this blue curve here that's in two parts. Now we wanted to know when that function was greater than 0. So we want it above this value, greater than 1. So we want it above this value of 1 here. So if you imagine a horizontal line running across there, our function would come up and it would hit a value of 1 when x was minus 3. So these, I've just replaced our t's with x's so that we could grab it. So when our t was minus 3, anything below that was giving us a value greater than 1. So in our answers, we had t is less than minus 3. We also had t is greater than 2. So you can see that this whole blue bit of the curve, that whole bit over here, that's greater than the value of 1. And if we zoom out, you can see that it's always going to be greater than 1. So it's never going to drop below this value here. It's actually never going to drop below 2. So this function called a hyperbola that we haven't looked at a whole lot yet actually has what are called asymptotes. So it's got a horizontal line running across at x equals 2 and a vertical line, a horizontal line at y equals 2 and a vertical line at x equals 2 that the curve's going to approach, but it's never going to touch. So this curve, this function, is never going to touch that line x equals 2. It's going to get incredibly close, but it's not going to touch it. So that means our value where this function is greater than 1 would be that x is greater than 2, or in our case, t is greater than 2. Okay, so like I said at the start, there are other methods of solving these harder inequalities. There's things that are called looking at the critical points and then evaluating where your inequalities go, that you can graph the original functions and read them from there. But this is the method that I prefer, so this is one I've shown you, but I am happy to show you a couple of others as well if you'd like.